Bismillahirrahmanirrahim. Hello everybody. Prove that, say in each case if the sequences un and vn are adjacent. First case, un is equal to the sum from k equal to 1 until a, 1 of k factorial, and vn is equal to un plus 1 over n factorial. This is the two cases. Are they adjacent or not? We can easily remark that un is less than or equal to vn for all n in n. Yeah. I mean n greater than or equal to 1. We should then prove that un is non-decreasing and vn is non-increasing. Let us consider un minus un plus 1 minus un. This is equal to the sum from k equal 1 to n plus 1, 1 over k, minus the sum from k equal 1 to n, 1 over k factorial, and this is equal to 1 plus n plus 1 factorial, which is greater than 0. So un is increasing, as we guess. For vn, we have vn plus 1 minus vn. This is equal to un plus 1 minus un. Vn plus 1, un plus 1 plus 1 plus 1 over n plus 1 factorial. And here we have plus 1 over n plus 1 factorial minus 1 over n factorial. You can verify in a very easy way. This is the difference, as we proved here, is equal to 1 over n plus 1 factorial. So we have 2 over n plus 1 factorial minus 1 over n factorial. And this is equal to 2 over n plus 1 minus 1. Here we have n plus 1 factorial is equal to n plus 1 times n factorial, which is less than or equal to 0. Why it is less than or equal to 0? Because n start from 1. So in the worst case, it can be equal to 1. So we have 1 minus 1 equal to 0, and this is positive, so less than or equal to 0. Otherwise, 2 divided by n plus 1 is strictly less than 1. This means that vn is non-increasing. This first. What do we have? We have vn is non-increasing and is lower bounded by u1, so it is convergent. Un is increasing and above bounded by v1, so it is convergent. Both of them is convergent. Let us consider the difference between them. If we consider the difference between them, we will obtain vn minus un. This is equal to 1 over n factorial, which goes to 0, 1 n goes to plus infinity. This means that un and vn are adjacent. The second question, or the second exercise, is I am here, is we define Wn by the sum from k equal 1 to n minus 1 power k over k. And we consider un equal to w to n, and vn equal to w to n plus 1. Does un and vn are un and vn adjacent or not? We remark that un is equal to the sum from, very important this step, the sum from k equal to 1 till to n minus 1 power k over k, and vn is equal to the sum from k equal 1 to 2n plus 1 minus 1 power k over what? Over k. We remark easily from this form that Vn has one element, supplementary element, which is 2n plus 1, but at the level 2n plus 1 here it will be negative, so Vn is less than or equal to n for all n greater than or equal to 1. This is very easy. Then we should verify that Vn is increasing and un is decreasing. Un plus 1 minus un, this is equal to the sum from k equal 1 to n plus 2. We replace n by n plus 1 minus 1 power k over k minus from k equal 1 to n minus 1 power k over k, and the difference between them, we keep two elements. The first one is minus 1 power k power to n plus 1 over to n plus 1, add power plus minus 1 power to n plus 2 divided by 2n plus 2. This is positive and small than this negative and big than this one. This means what? Less than 0. This means that un is increasing. This means un is increasing. How about Vn? Vn plus 1 minus Vn. This is equal to the sum from k equal 1 to n plus, we replace what? We replace n by n plus 1, so plus 3 minus 1 power k over k minus the sum from k equal 1 to n plus 1 minus 1 power k divided by k. And here we keep two, we have two remainder elements, minus 1 power to n plus 3 over to n plus 3 plus minus 1 power to n plus 2 divided by 2n plus 2. This is positive and greater than this negative one. This means that greater than 0, which implies that Vn is increasing. Here, sorry, decreasing, since it is less than 0, so it is decreasing. It seems that I am tired. Decreasing, and this is increasing. Vn is increasing and upper bounded by u1, so convergent, and un is decreasing and lower bounded by v1, so convergent. How about the difference between them? We will solve. We will consider the difference between Vn and un. We have un minus Vn. The sum from k equal 1 to n, minus 1 power k over k, minus the sum from k equal 1 to n plus 1, minus 1 power k over k, and the difference is equal to minus 1 over 2k plus to n plus 1, to n plus 1 over to n plus 1 with minus sign, so plus 2. It doesn't matter, it doesn't mind, and this goes to 0 when n goes to plus infinity. This means that un and Vr are adjacent. I think that I will stop here. Yeah, it's okay. So this is for today. See you next time.